Okay, now we can move to the next question of part B question of question 1. Okay, let's move to the question. The part B question is the we have to find the change of internal energy. We have to find the internal energy of the gas. Okay, the change of internal energy. We already know Q is equal to. We already know U is equal to mc into delta T. We we all familiar we all are familiar with this equation already. Q is equal to mc into delta T. We use this equation for this to find the change of internal energy. Because Q is already energy, no. We already find here energy transfer. Q is equal to delta Q. Delta Q means energy transfer. It may be uh, energy comes to the energy comes to the container or energy released from the container. Oh, guys, okay. Therefore, this equation is used for energy transfer. This Q is equal to mc into Q is equal to mc into letter E. Here the important thing is uh, we we have Q is equal to mc into delta T. We already know which C, we already have Cp and Cv. There is Cp, Cv also. Ne? Wha- What what should we substitute here? Should we substitute in this C? In this C, what value should we substitute? Cp or Cv? That's the main thing in this equation. That's other things are very simple. We must memorize that. Here we must include Cv. This Cv is here in this equation. In this equation, the C is Cv. That means uh, specific heat capacity of the gas at constant volume. Cv means constant volume. Cp means constant pressure. Cv means constant volume at specific heat capacity. Specific heat capacity at constant volume. Okay. Then now we have to find. Oh, you already know Q is equal to mc into delta theta delta T. Here we modify this equation a little bit. Only we substitute delta U instead of Q. Here we use Q is this in general equation for heat transfer. Here delta U is equal to M into Cv into delta T. Same equation. Here we must do some modification. Very main thing is here we use C here Cv. That's the main thing. Okay, main Cv. We here the equation is internal energy. No, the change of internal energy. Therefore, we mostly use U for internal energy. This U for we already used this equation for A level time also. If we want to find the internal energy, we use U for internal energy. Okay, this is same thing. Q is equal to mc into delta T. We delta T is equal to m into this is the main thing. This Cv that is main thing. Therefore, we can find the internal change of internal energy. Delta U is equal to m. We already know m is equal to 0.9 kilogram. 0.9 kilogram into Cv. What's the now? What is Cv? 0.6534. 0.6534. 0.6534 kilojoule kilogram minus 1 Kelvin minus 1 kilojoule kilogram minus 1 Kelvin minus 1 into delta T. Delta T, which is delta T is 500. Delta T is 523. You already know 523.15 Kelvin minus 288. 88.15 Kelvin. Now if we find delta U is equal to final answer 138. 138.194 138.194 kilojoule. This is the answer of part D question. Delta U is equal to 138.194 kilojoule. Kilojoule, kilogram, kilogram minus 1 cancelled. I use another color. Kilogram, kilogram minus 1 cancel. Uh, Kelvin, same Kelvin, Kelvin, Kelvin minus 1 cancel. They have a kilojoule. They have a kilojoule. We have to consider also this unit also. Sometimes we may find joule. We can find if we substitute joule instead of kilojoule. Is wrong answer no. Therefore, we have to consider about this units also. Okay, that's it. We here in this equation we have to only memorize mostly this same equation Q is equal to mc into Q is equal to mc into delta t. Here instead of Q we substitute delta U for internal energy. In earlier advanced level also we use U for internal energy. Here this is very important. He must substitute CV for the C. For specific gas constant, we must substitute CV. Don't substitute CP here. We must substitute special gas constant at constant volume. Okay, that's the question. The final answer is delta U is equal to 138 1.4 kilojoule. Uh, we must consider about this unit because we don't know. We already know if the delta is energy, therefore the answer will be joule or kilojoule. Therefore, if we find therefore if we consider the units, we can decide whether it is joule or kilojoule. Okay, this is the simple question. Now we can move to the next question. Bye.